Okay. So coordinate system. Let's say you are here. Sorry. So coordinate system. Let's say you are here, and A is here. Okay. What the distance between A and this point? This point is 0. So we do some calculation. Okay. For example, let's say 10 meter. Okay, 10 meter is the distance from from 0 to A is 10 meter. Okay, this one is A point is here. A point 10 meter. Okay, this one we call 1D, one dimension. Okay, let's say we move point A to here. Point A. So how to determine the location for A? Okay, how to determine the location for A? We use 2D. 2D system. For example, we use this one is x-axis, and this one is y-axis. Okay. Location for A is 1, 2, 3, 4, 5. 5. 1, 2, 3, 4. Okay, let's say 4. 4 lah. Okay, 4. The location for A is 5 x-axis and 1, 2, 3, 4. 5 x-axis and 4 y-axis. So we can say that 5 4. Okay. This is location for. Hello? Okay, just now my computer is hanging. So I need to start back. Repeat again. Okay, location for A is here. Yeah, location for A is here. So what is the location for A? How to determine location for A? So we calculate 1, 2, 3, 4, 5. 1, 2, 3, 4. So 5 here, 5 step x-axis, and 4 step y-axis. So location is 5, 4. Okay, this one we call 2D. 2D system. So the coordinate system. So 5 to the right and 5 to the top. So location for A is 2D. Okay, we can write as 5/4, or we also can write, we can calculate the distance from point 0 to point A. Okay, this distance. How to calculate the distance? By using trigonometry. This one is 3, 5, that is 4. 4 and 5. So the location is from 0 to point A is equal to square root 5 square plus 4 square. Okay, that's this distance. This magnitude. And also we have to write this angle. Okay, now we have two types of representation this point A by using coordinate system, pi 4, or by using polar system. Polar system, magnitude, and angle, theta. Okay, this one is for 2D system. Let's say we have this point is here. Okay, I have. Okay. This is 2D system. This one show direction of x. This one show y axis. So point is here. 2D system. If point is here, let's say this at here. P at here. Okay. This is our. So we have to implement one more. We have to introduce one more axis. We call z axis. This one. This one we call x axis, y axis, and z axis. So this is in 3D system. 3D, yeah? X, Y, Z. Let's say our point is in between at the center of this one. So how to determine the location for this P? So by using Cartesian coordinate system, we can determine the location for D, for that P. So we will have to introduce one more axis. Okay, Z, Y, X. Okay, this axis, X, Y, and Z. So the point P is here. Point P is here. Here, point P. So we have to point X and Y. This is X, this is Y, and this is Z. So point P is equal to coordinate X, coordinate Y, and coordinate Z. Okay? Also, we can determine by using magnitude. This is our point P. This is point P. So the distance from P to, we check this, calculate this distance, this span distance, and also the angle. Okay, we have this kind of magnitude. This magnitude is equal to x squared plus y squared plus z squared. Okay, this one is Cartesian coordinate system. And we have another two 3D. This one we call 3D system, 3D. 3D because we have 3 dimension, x, y, and z dimension. So we call 3D dimension. Okay. This point P also we can use one more technique in 3D. We call cylindrical coordinate system. As I explained last week, cylindrical coordinate system. Okay, this is point P. Point P. So by using cylindrical coordinate system, we draw a cylinder here. This one cylinder. Okay, we draw a cylinder. Now the cylinder. Okay, if we look from here, we put our eyes here. Eye. This is your eye. E-Y-E, your eye. Look from here. What we can see is, okay, this is our X, Y, Z axis. X, Y, and Z axis. So if point P is here, point P is here, and then we use cylinder. We use cylinder. This one cylinder. So if you look from this angle, from Z axis, our eyes is from Z axis. What we can see is This one. Okay. Oh, sorry. Okay. Like this. This circle is top of the cylinder. Top of the cylinder is circle. And then from the cylinder to point P is we got R. Okay, R is from point P to from Z axis to point P is R. This is X axis. This one is Y axis. So if we focus on this part, what we can see is here. Okay. This one. R. R is distance from the center of our cylinder, from the center to point P. This is R. Okay, if you look from top, if you look from this part, okay, our eye is here. We look from x-axis. This is our eye. Okay, what you can see is our eye. Okay, this part. Okay, here, cylinder, just a rectangular. Okay, rectangular. What we can see is rectangular. The distance of point P and Z axis is R. Okay, like this. This is our point P and R. This is H. This is our Z. Z called Z axis. So this is point P. It look like rectangular. Okay, this is point P. All right. If you look from here, this is point P. Point P. We look from here. We look from here. From this axis, we can see this one. And we zoom from here. Zoom direct. The bottom, what we can see is this is our radius, point P, and this one is angle. Angle between x-axis and R. Okay, it's angle. Phi, angle phi. Okay tak ni? Angle phi. Okay. So the derivation for the derivation for angle this angle phi. This is point P. This is point P. This is R. Z, Y, X. So point P, this is R. This also R. This is point P. Okay. This one is X. This one is Y. This one is Z. So last lecture, I already show you how to get theta, phi, how to get R. Okay, the coordinate for cylinder is R, P, and Z. R is the distance from the distance of the, I call this one, from Z axis to point P is R. Phi is the angle from X axis to R. Angle from the Z is the value here. Z is the height of the cylinder. Okay, height of the cylinder is H. Value Z. Height of the cylinder. Okay, that one is for cylindrical coordinate system. So I explained last week, and not last week, and last lecture, how to the relation between x, y, and z, and r, phi, and z. X, y, z is Cartesian, r, phi, and z is in cylindrical coordinate system. Okay, so today we will continue for third 3D system we call spherical coordinate system. So spherical coordinate system. We have z, x, y. So again, point P is here. So how to locate point P using spherical coordinate system. So for spherical, we have draw spherical. Okay. Spherical coordinate system. You like ball, So for spherical coordinate system, if we look from, if we cut this part and this part to quarter, what we can see is like this. Okay, this is point P. Point P is here. So this is Z axis, X axis, and Y axis. So point P is here. By using spherical coordinate system, we can cut into quarter, and this is your spherical coordinate system. So we have P here, point P. The distance from 0 axis to P we call radial is R, and the angle between radial and Z axis is theta. Okay, if we look from here, if we look from this, OI is here, what we can see is like this. This one. Okay. Theta is angle from between Z axis and R. All right. So if we look from here, our eye is here. What we can see is we plot it. Plot this one. This is phi. Okay. This is point P. Like this. Sorry. Okay, point P. This one is okay. When we look from here, this is angle R and point P, and we plot it. Plot it is point P. We see from Z axis. Okay, like this. Point P is here, and the angle between X axis to this point P we call phi. This one, theta and phi. Okay, the angle here, theta, the angle is phi. This is our R. Okay? Can you imagine it? Hopefully this will help you to imagine the coordinate for spherical. So now we will derive. So now we derive. Okay. Okay, coordinate transformation. So coordinate transformation, first one is using coordinate system. Second one using cylindrical, and third one using spherical. For coordinate system, we have x, y, and z. For cylindrical, we have r, phi, and z. And then for spherical coordinate system, we have capital R, theta, and z. Theta is angle between, theta is here, angle between R and z axis. Is theta. R is radial and Z is, oh, sorry, it's not Z. It should be, wait. Got spherical. Okay, Z. Okay, sorry, yeah. Okay, Z. Z is point at Z axis. The value of Z axis. Okay, this is our Z, X, and Y axis. Point P is here. This is R, theta. Again, we plot. This is phi. Y, X value. Okay. Okay, R. So from this triangle, okay, this triangle, we can find this value. We have theta here, we have 90 degree here, we have R here. So this value will become R cos theta. Okay? And this value will become R sine theta. This is Z. A coordinate for Z as this. Alright? So Z equal to R sine theta. Okay, Z is equal to R sine theta. Okay, next is what is the value of R? So R is R. R is distance here, theta. Okay, that is value for spherical coordinate. Okay, this distance is equal to this distance. Okay, this one and this one same. So R sine theta. Okay. So we have phi here, angle. Sorry, you need to change color. Just put blue color again. Oh no, green. Okay. So we know this distance is equal to R sine theta, and we have phi here. So we can calculate this value. This value. So it means that this value will be equal to this one cos phi. So R sine theta cos phi. Yeah, this distance. R sine theta cos phi. This is x. This one is x. So x equal to R sine theta cos phi. X equal to R sine theta cos phi. Okay, next is value for Z. Sorry, Z we got it, X got it, and it's Y. Value for Y. Y is here. Y equal to, okay, this theta, sorry, this phi, and we have R sine theta here. R sine theta is here. So this one will be equal to this distance sine phi. Okay? Y will be equal to this distance. Okay, this distance is equal to R sine theta. So sine phi. Okay? R sine theta sine phi. Okay? Opposite with the Y, X. X is R sine theta cos phi due to phi is here. This is R sine theta cos phi. This one is R sine theta sine phi. Okay, so here value for Z, X, and Y. So from this, we can say that this is a transformation from spherical coordinate to spherical to Cartesian. Okay, this Cartesian, why is that Cartesian? Spherical is, okay, spherical R, theta, and Z. Cartesian, X, Y, and Z. So from Cartesian, from spherical to Cartesian is using this formula. Z equal to R sine theta, X equal to R sine theta cos phi, Y equal to R sine theta sine phi. Okay, so it's from spherical to Cartesian. Next is from Cartesian to spherical. So from Cartesian to spherical, what is value of r, what is value of theta, what is value of z? R equal to, so r, where is r? R is here, so need to change color again. Oh, sorry. Okay, draw again lah. Okay. This one is value of z. This one r, phi. So what is r? We know that for Cartesian, x, y, and z. So for cylinder spherical, r will be equal to x square plus y square plus z square square root. Okay, this is distance. We have z here. This one is y. This one is x. So magnitude for r will be equal to x square plus y square plus z square. Okay. Next is for theta. What is theta? Theta is here. So theta is there. Okay. Phi. What is phi? We know that this x, this one is y. Distance is y, this distance is x. So phi will be equal to inverse tangent y over x. Okay, this y, this one is x. So y over x, phi is tangent y over x. Okay, next is theta. Theta will be equal to okay, this one is this. This one is r sine theta. Okay, r sine theta. This one is r cos theta. Okay, this tangent will be equal to this one divided by this one. Z. Okay, Z equal to this one. Okay, r sine theta, Z this one. So by using value of x and y, we can determine Z. This Z. Okay, this one will be equal to y plus x square root. Okay, this one also this value x square plus y square root. Okay, so it's same. Okay, theta equal to this distance. This we call this one is this one divided by this length. This length is equal to tangent x square plus y square. Okay, tangent this one divided by this one. This one is z over z. Okay, this is the value for the formula for theta, formula for phi, formula for r. So for spherical coordinate system, r, theta, and z. So r equal to the magnitude of x, y, and z. R equal to the magnitude for x square plus y square plus z square. Theta equal to tangent x square plus y square square root divided by z. Z equal to z. Okay. Any question? Okay, this one is the table for a transformation from Cartesian to cylindrical, from cylindrical to Cartesian, Cartesian to spherical, spherical to Cartesian, cylindrical to spherical, and spherical to Cartesian. Okay. Is there an example? As an example. Okay. Then that's all. So any question for today's lecture? I think today we need to stop here because I have a meeting after this. Sorry. So we'll continue next Monday. So any question? Hopefully you can understand for today's lecture by showing all the okay, no question. I think that's all for today's class. Thank you very much.
Thank you, Doctor.
Thank you,
Thank you,
Doctor.
Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.